So this article is in the debrief. A living fossil has been discovered alive in California's coastal waters. In 1938, a discovery was made off the eastern coast of South Africa that shook the science world. A peculiar fish was discovered among the day's catches of a group of local fishermen. And fortunately, a museum curator named Marjorie Courtney Latimer, was on hand and noticed the primeval-looking specimen. Upon contacting Rhodes University ichthyologist J.L.B. Smith and sending sketches she made of the fish, Smith dispatched an emergency responding cable that read, "Most important, preserved skeleton and gills equals fish described." Smith's urgency was based on the fact that, rather than being a new species, what Courtney Latimer had found was something he recognized from the fossil record. Remarkably, the specimen appeared to be a variety of ancient fish known from the late Cretaceous period as the coelacanth, a kind of transitional species whose curious fins placed it someplace within the evolutionary lineage between fish and tetrapods. So the coelacanths are also known as lobe-finned fish, and you can see here in this restoration, this picture, this model, that their fins don't protrude directly out of the body. The fins are actually grown at the end of these fleshy lobes, these little muscular protrusions. And these muscular protrusions would evolve, this would be the basis for the evolution of all the limbs of tetrapods, like vertebrates, mammals and reptiles and other fish. Well, I guess fish aren't tetrapods, but like amphibians and reptiles and mammals and birds. So this key physiological feature here was really important to vertebrate evolution, to our evolution. Now, continuing the article. Since the famous discovery, several similar instances of living fossils have been discovered. So yeah, the coelacanth is not what today's news article is about. This is about something else. The most recent of these turned up in an unlikely place, off the southern coast of California. Discovered alive within the waters of Naples Point, slightly north of UC Santa Barbara, is a small variety of clam, previously known only from the fossil record. Jeff Goddard, a research associate at the Marine Science Institute at UC Santa Barbara and co-author of a new paper detailing the discovery, says it is remarkable, partly due to the location where the specimen was found. It's not all that common to find alive a species first known from the fossil record, especially in a region as well studied as Southern California, Goddard said in a statement released by the university. Comparing the find to the famous discovery of the coelacanth in the late 1930s, Goddard notes that what he and his colleagues turned up at Naples Point doesn't go quite as far back as the famous ancient fish did, quote, representing an entire class of animals thought to have disappeared 400 million years ago, unquote. Still, Goddard notes that the remarkable little bivalve they found, quote, does go back to the time of all those wondrous animals captured by the La Brea tar pits, unquote. The discovery was made in November 2018, as Goddard had been searching under rocks at low tide for a variety of sea slugs when he noticed not one, but instead a pair of tiny translucent clams. As he observed them, he noticed that they possessed a white striped foot that exceeded the length of their shell. This is the foot right here. Goddard then realized that he recognized this species, even though that seemed impossible. This is a picture of specimens of Cymedioa cooki photographed by Jeff Goddard. Mirroring the coelacanth discovery of almost a century earlier, Goddard, rather than procuring sketches, took high-quality images of the pair of bivalves, opting to leave the pair in their natural habitat. The images were immediately sent to Paul Valentich Scott, Curator Emeritus of Malacology, or the study of crustaceans, at the Santa Barbara Museum of Natural History. Like Goddard, Valentich Scott found the appearance of the little creatures intriguing, as they were unlike any of the well-known similar species along the California coast. Ultimately, it was decided that a specimen would be needed after all, but by the time Goddard returned to Naples Point in search of his new quarry, the mysterious clams proved more difficult to find a second time around. In fact, such would be the case over the course of several more failed attempts to rediscover the tiny creatures. After 9 attempts over the course of the next several months, Goddard finally managed to relocate the creatures, this time a single clam, beneath the rock alongside 2 of the nudibranch sea slugs that he had originally come to Naples Point in search of. So initially, he thought he might have uncovered an entirely new species. When I suspect something is a new species, I need to track back through all of the scientific literature from 1758 to the present, the curator said in a statement announcing the discovery. It can be a daunting task, but with experience it can go pretty quickly. After poring over data in the museum's collections, including fossils of similar species known from California's prehistoric coasts, the 2 researchers uncovered drawings of a variety of bivalve, Bornea cooki, first described in 1937, just 2 years prior to the rediscovery of the coelacanth, which looked like a match for the tiny long-footed California clams that Goddard had found. After comparisons between the original fossils discovered by George Willett in the 1930s with the new specimen, as well as a single shell Goddard retrieved during a subsequent visit, a positive match was confirmed. Willett's original discovery, now given the classification Cymadeoa cooki, was indeed still alive in California's coastal waters. Another living fossil had been confirmed. So here's looks like a picture, another picture of the Cymadeoa cooki, the latest living fossil discovered off the California coast. This is really interesting. It's barely pigmented. It's pretty pale, but it does have this white stripe on its foot. Makes me wonder if this is like a dense concentration of muscle tissue and the rest is just dermal tissue, or perhaps there is transparent muscle tissue running throughout it, because it is the foot organ after all, and it's pretty much a straight muscle. And this could be pigment or a line of fat surrounding perhaps a core neural structure. I don't know. Really interesting though. This is a ghostly, spooky, but really kind of ethereally beautiful looking little mollusk. Noting the intertidal boulder fields that cover broad ranges of the California coast, Goddard says he thinks it's likely that the newly rediscovered living fossil, Cymadeoa cooki, is probably living in close association with animals burrowing beneath those boulders. There is such a long history of shell collecting and malacology in Southern California, Goddard says, admitting that, quote, it's hard to believe no one found even the shells of our little cutie, unquote. Indeed, sometimes the most remarkable discoveries turn up right under our noses, and in Goddard's case, quite by accident. And so now I've opened up the paper that we can take a look at. It's a pretty brief paper, all things considered. We don't have to get into all of it, but let's look at the abstract and then perhaps some of the introduction to get some background knowledge, and then we can skim down to the discussion. A small bivalve mollusk, previously only known from the Pleistocene of Los Angeles County, has recently been found living intertidally near Santa Barbara, California. The bivalve has been determined to be Cymadeoa cooki, a member of the Galimatoidea. We document the habitat for the newly discovered C. cooki and compare it to C. electalis, the other extant member of this genus recorded from the region. Cymadeoa cooki is rare, and while many galeomatoid species have been shown to be commensal with other invertebrates, we have been unable to determine any specific commensal relationships for it. Okay. So let's skim the introduction a bit. The invertebrates inhabiting the rocky intertidal zone of southern and central California are among the most studied and documented in the world. So this is why they were so surprised to find a bivalve that was known only from the Pleistocene. This small translucent bivalve is clearly identifiable as a member of the frequently cryptic yet exceedingly diverse superfamily Galeomatoidea. Our recently collected specimens belong to the poorly understood genus Cymadeoa, and there's only one other living representative of the genus. Let's see. So the first example of this, the fossil specimen, was documented by that guy Willett at Baldwin Hills in central LA during the time a sewer line was being installed. The sewer trench uncovered a 20 to 30 centimeter thick Pleistocene deposit of invertebrates and vertebrate fossils, approximately 4 feet below ground level. In his publication, Willett recognized 296 species of mollusk and described 2 new species of Galeomatoidean bivalves, Rochefordia rayana and Bornea cooki, now known as Cymatia cooki, or Cymatioa cooki. Man, I'm having trouble pronouncing some of these names. So they estimated the Baldwin Hills deposits to be between 36,000 and 28,000 years before present. The deposits range from 78 to 146 meters above current sea level and are approximately 10 kilometers from the modern coastline. Okay, so here we have a figure. We can come back to that figure when it loads, of the Cymatioa cooki. Here's the systematic account. So we have some taxonomic information, the superfamily, the family, relatives, basic physical description, and okay, here's the discussion. Okay, so it looks like it's just a more technical descriptions of the body parts. We have the shell, the mantle, the foot. Okay, let's look here. A bright white stripe extending from the tip of the foot to the shell margin, presumably related to the byssal formation. Figure 1A. Okay, so this is figure 1A. I don't know what the byssal formation is, but sounds interesting. So this is pretty cool. Here we can see we have a side view, and then, or I guess this is the top view, and this would be, figure B here would be the side view, because we're seeing the foot coming out of the shelves of the bivalve. That's really interesting. Here's some of the original pictures he took. You can see the foot again. The shell, I got some gunk on it. That's what I'm saying. Very cool stuff. So that's the next news story. Discussion. Okay, yeah, let's finish this up by reading the discussion. Previously only known from the Pleistocene of Los Angeles, Cymatioa cooki is herein recorded living for the first time. Only 3 living specimens have been discovered to date. Despite C. cooki's potential commensal relationship with burrowing invertebrates, we have not sampled the intertidal infauna deeply enough to discover the potential true habitat for the species. Depending on the lifespan of C. cooki, the adults we observed at Naples Point may have been transported as larvae from much farther south during the marine heat waves of 2014 to 2016, which drove northward numerous marine species distributions in the northeastern Pacific, including populations documented specifically at Naples Point. This might explain why the second author did not find C. cooki at this site prior to 2018, despite intensively searching the same underrock habitat for heterobranch sea slugs at Naples Point since 2002. Other Baldwin Hills Pleistocene bivalves reported by Willett in 1937 have been documented as living in Southern California. Motylus adamsianus, which is, it equals Brachydontius adamsianus, is a common modern rocky intertidal species from Santa Cruz Island, California to northern Peru. Ensis californicus and Petricola talamayalis are also found intertidally in Southern California, with the former in sandy protected environments and the latter associated with giant kelp holdfasts. The Cymatioa specimen described by Willett in 1937 was named for a Miss Edna T. Cook, who collected the specimens. Well, that's nice of him. The original discoverer named it after the Edna Cook, an assistant who helped him collect them. That's nice. You know, you gotta have tokens of appreciation for all the people who help you along the way with your research. That's awesome. Given the small size, translucent shell, and cryptic habits of C. cooki, it is not surprising that living instances of the species have been overlooked for 80 years. We are confident that its description here will lead to the discovery of further examples in Southern California, and likely even further south into Mexico. Well, that's pretty cool. So, yeah, they found a living fossil, kind of like the coelacanth, except it's a mollusk. It's some kind of bivalve. Very cool stuff. And yeah, like it's really interesting how they said that they were surprised to find it in Southern California because it's an area that's been so extensively researched by all kinds of biologists doing all sorts of research projects. And so to find something new there, especially in some of these the intertidal zones, these coastal habitats that are so heavily studied, was surprising to them. But then one of the speculated reasons was that some of the heat waves that we've had over the last decade have been so intense that they've caused a lot of marine species to move around to try and find more comfortable waters. And so they were hypothesizing that a lot of animals that lived in more southern areas had moved northward to escape the heat and of those heat waves. And that's why the author discovered these creatures now and not several years earlier. When he'd been, doing some earlier, perhaps graduate or PhD work. In any case, this is super cool, and it does kind of stoke your imagination and makes you wonder what other kind of living fossils could be out there. Because, we had the coelacanth, now we have these fossils. There's a whole bunch of other stuff out there too that we've discovered that has previously only been known from the fossil record, but you really have to wonder what else is out there. Not to get too silly, but it makes you wonder about stuff like the Loch Ness Monster. Like, there almost certainly isn't a Loch Ness Monster, but is it possible that there's some deep sea Paleozoic predatory marine vertebrate, like a marine reptile, that survived all these mass extinctions over hundreds of millions of years, and we just haven't discovered them yet? They're still lurking somewhere in the deep in some underwater cave habitat somewhere. It's always possible, and it's really fun to exercise your imagination and think about how these living fossils, certain examples, certain specimens, certain species, might still be alive, where they could be, and if we discover them, just what they might look like, what the context of that discovery might be, and what we can learn about their evolution or lack thereof, and their relationship to other animals and all sorts of stuff. It's just endlessly interesting stuff. You gotta love it.